This is Summer 2009 Math 263 Test 3 number 5. Use Lagrange multiplier method to find the dimension of the box with greatest volume, provided that the surface area is 10 meters squared. Now here we need to first define the function we need to maximize and also define the constraint. Now the function we need to maximize is the volume. Maximize volume, which is, if there's a box, let me draw it here. If the box looks like this is x, y, z, then the volume will be x, y, z. Okay, and then the constraint, the surface area, let me use S instead, is twice the base, twice the side, and twice the other side, right? 2 times xy plus yz plus xz. Okay, now according to the Lagrange multiplier method, del v equals to del lambda del s, and of course the constraint should be satisfied. Oh, this is equals to 10. The s equals to 10. Okay, the surface area should be 10. Now if I break it up further, you will see del v will be yz xz, and here I have what, xy equals to 2 lambda y plus z, and then x plus z. I take the 2 out already, and x plus y. And again at the bottom, the surface area, 2xy plus yz plus xz, this should equal to 10. Okay, this should be equal to 10. Now on the top you see that, notice that, let me break it up. Yz equals to 2 lambda y plus z, and xz equals to 2 lambda x plus z, and then xy equals to 2 lambda x plus y, and finally xy plus yz plus xz equals to 5. Right? Now this is the thing, we are so tempted to put this in, to add all of these here and say this equals to 5. But instead of doing it that way, let's think a bit about this. Notice that the volume has to be a positive number, okay, and none of the x, y, z should be negative. So from here we say that x and y and z has to be strictly positive number. Is it okay? Has to be strictly a positive number. Now, in other words, then I can multiply this by x. I get xyz equals to 2 lambda xy plus xz, and I will do likewise for the second and the third. Okay, why? Because I want to have xyz on the left hand side, and my plan is later on I equate the right hand side. Notice that all of them equal, right? So from here, let me go on. This will be 2 lambda xy plus xz equals to 2 lambda xy plus yz equals to 2 lambda xz plus yz. Okay, now notice the following, that from here you see that lambda will not be 0. Why? If lambda is 0, then xy, either one of xy is 0, or xyz, either one of xyz is 0. Okay, now but that will make violate that thing. Okay, so we know that from here that lambda is not equals to 0, otherwise x, y, z equals to 0. Okay, one of them should be 0, or even two, or all of them will be 0. Now in other words, because lambda, no, I'm sorry, I should say not equals to 0. Because lambda is not 0, then I can divide by lambda all these three sides here. In other words, we have xy plus xz equals to xy plus yz equals to xz plus yz. Now in the first equation, you can cancel the xy and divide by z. Notice that z is not 0, so I can do so. From there I will see that maybe I write it down a little bit, that xz equals to yz, right, from the first equation there, and therefore x equals to y. Now from the second equation, let's call this the second equation, xy equals to xz, and because x is not 0, then y equals to z. In other words, you will see that x equals to y equals to z, all of them should be the same value. Now I will do this, I'll put this now into the constraint. When I put into the constraint x, y plus yz plus xz equals to 5, I will substitute everything becomes x, so it will be 3x squared equals to 5, x equals to square root of 5 over 3. Okay, now which is equals to y, which is equals to z. Okay, so what is the volume? Maximum volume will be x, y, z equals to radical 5 over 3 being cubed. That's 5 radical 5 over 3 radical 3. Dimension, again, x, y, z are all, maybe I simplified it a little bit, there will be radical 15 over 3 meter. Okay, and this is the volume here, hold on, this is 5 radical 15 over 9 meter cube. That's the maximum volume. Okay, I hope you can see the big picture here. Let me bring it down. Okay, now you may find another way to do it. It doesn't have to be this one. Okay, this is summer 2009 math 263 test 3 number 5.